First, when we start the class, we should have a prerequisite things. What are the things we need to know before starting the lesson? Okay. I will give you certain hints so that you can guess the topic of the today's lesson. Okay. I will give certain keywords. Let's see if you are able to get the topic with the keywords itself. Okay. Number one is Google Maps. That is keyword number one. Yes. Navigation. That's a good guess. Okay. Direction. That's a very good guess. Next thing is speedometer. Magnet. Good guess, but I said speedometer. Very good. Speed, velocity. But first I said Google Maps also. In Google Maps, distance. That's a very good. Okay. Next, this is a tough one, but let's see if you are able to get that. Okay. In math, we call two types of quantities. Okay. In math, quantities are categorized into two types according to whether they have direction and magnitude. Okay. Does anyone know what is that categorization? Yes. This is how you see vectors and scalars. You got it right. So distance, displacement, speed, scalar, vector, all these are going to be in our today's session. Okay. Before that, children, there is something wrong with this blackboard. What is it? Green board. That's the first mistake. Okay. No, as a responsibility of students in the classroom, we have missed something in this blackboard. Yes, very good. So we have missed the date. What is the date today?
27.
What is the date today? So that is all these things we have to discuss in this because it's more important. Okay. So our next thing, we should have written what? School name. Then our motto of the school. Right. So, as you guessed it right, the topic for the day is distance and displacement. Okay. To start with that, let's use a teaching model with which you can understand it better. So this is what we are going to do. Now, as I do that, I just want one person to get up and narrate how do you come from your home to school. Anyone, please get up and say, when do you start? How do you come? When do you reach? Yes.
I come by walk.
Okay.
Start by 8:20.
8:20.
Start by 8:20.
8. You start by 8:20 and you reach by? Okay. Right. So now a similar model I have here. Okay. Now we have a person. This person is taking a journey from their position to maybe a friend's house. That's what he is going to do. Okay. What he is going to do is he will start from this position, take the road, go like this, and he will reach there. Okay. Now making use of the threads, we are going to understand two things. Right. Let me use this thread. So sometimes this happens when teaching. So first he goes like this, then he goes like this, then like this, like this, like this, and here. Isn't this his journey? Yeah. So this thread, if I take the measurement of this thread, it will give me a value from this point to that point. So this length will give me a value. The other thing that I can do is, I can take this. From that position, directly I can link this position. Okay? So I can take a ruler scale and I can measure this green thread's length and also the blue thread's length. Okay? With this, how can I differentiate both of these? What is the difference in these measurements?
These are distance, short.
Shortest distance.
What was the difference in this measurement?
This is short cut and that will take more time
That is more time.
and longer distance.
Yeah. Sit down. So this is the whole concept of what we are doing today. So the first thing that I did with the blue thread, I actually covered the pathway, the journey of the person. So that is called as the distance. When I measure the total length covered by a person during their journey, the total length is called as the distance of the journey. But when I just measure the shortest distance, as she said, the shortest distance from the starting point to the ending point, that measurement is called as
Displacement.
That is the difference. Okay? So when we write it as a definition, can someone come up with the definition? I just said it now. Let me see if you are able to remember. Can someone say what will be the definition, please? What is it?
Distance, the length between starting point and ending point.
Very good. Almost right. So how do we define that? Is the total length of the actual path of journey of an object is called distance. Now, what is displacement? Who can volunteer? How can we define displacement?
The shortest distance from one point to the endpoint. Means the starting point.
Starting point. That is important. So, displacement can be defined as the shortest distance possible. And do you know the shortest distance is always what shape would it take? The shortest distance between the starting point and ending point, what type of curve will it be? Straight line. That's the thing. When you take a shortest distance, it cannot be anything else but a straight line. Okay? The shortest distance between the starting point and ending point. Okay, we have understood this. Now, let's connect the math concept here. The concept of scalar and vectors. Out of these two, which do you think will come as a scalar, which could be a vector? First, let me revise what is scalar. Scalar is a quantity which can have only magnitude, which means a value. Vector is a quantity which has both magnitude and also a direction.
So scalar is distance.
Yeah.
Vector is displacement.
Yes. Okay. Before that, can we say some examples for scalar? What are all the quantities that we know, which you think it cannot have direction but only values?
Mass.
Mass, that's a good thing. Next.
Weight. Oh, weight will come.
Weight actually, it is a confusion in physics. Usually, what we are measuring when we take a weighting machine, we measure the weight of it. But in physics terms, weight is actually the force of attraction between the body and the earth. But in practical terms, we are using it as if it is a scalar quantity. But the distinction is mass is a scalar quantity and weight is a vector quantity. Okay, come up with some other example. What would be a scalar? Length. Yeah, when we say length, the length between me and some person, I can only say 10 meter or 100 meter. What is the quantity for which I can also attach a direction? Can you come up with some quantity for which, along with the value, I can attach a direction? Distance. No, distance is just the length. It's a matter. Force is something I can say 5 Newton I am giving to this table. 5 Newton of force. That 5 Newton is the value. But where is the direction here? Downwards. 5 Newton downwards is the direction. So when we have a car, the car is traveling 20 km per hour. This information is vector or scalar? A car is traveling 20 km per hour. Is it a vector or scalar?
Vector. Vector.
Scalar. Because I have said only the value 20 km per hour. If I had said a car is traveling 20 km per hour towards east, then that would be vector. Okay? Now, out of these two things, distance is always a scalar quantity. You can only talk about value in this. And here, displacement is a vector quantity. Now comes the question, how can I even assign a direction for this one? For our example, where this person started from this point and went to this point, how can I associate a direction for this? Yes, starting from this point, the person is going like this. So that is the direction of the journey. So if I can draw here, from this point, if the person is going here, then the direction is going to be like this. Okay. So I can assign a direction for this quantity. So that's why displacement is called as a vector quantity. Now,
displacement also, first point you have this direction, next point you have this direction.
Yes.
There also you can associate direction. No?
yeah, but if I am assigning a vector here, I am talking about which two points? This point and this point. If those 2 points I am talking about, then the displacement is like this. If this and this I am talking about, then the displacement is like this. So, the displacement is always dependent upon which 2 points you are talking about. Okay, that is it. Now, when we come to the unit, what would be the unit of distance? Meter. Yeah. So, unit of the quantity is distance is meter. Luckily, displacement also, the unit is meter. Okay. Now, we have come to the last topic that we will discuss. And small extension to this is how fast is it changing? Okay. So we know that a person is moving. He is covering some distance. If we say how fast he is covering that distance, then that quantity is called as, can you guess? There is a physics quantity which will say how fast distance is being covered. Speed. Okay. But we also have another word for that. Velocity. Now, what is the difference between speed and velocity here? Yes.
Speed is only the distance, that is in speed, along with the direction that is distance.
Exactly. So, with the car example, when I say 20 km per hour, that is speed. When I say 20 km per hour towards east, that is velocity. So, here speed is equal to distance covered per unit time, and velocity is equal to, can you guess? Displacement divided by time. That's all. One last thing. What could be the unit of this quantity? We have a quantity speed, meter per second. Can you explain to others how can we know this meter per second? It is not meter per something else.
Because distances we can measure in
Meter and the time, that is SI unit, time is SI unit is seconds only. So, it is
Exactly.
automatically answered.
Yeah. Even if you don't know the unit of a certain quantity, just go to its formula. The formula is distance by time. You know distance unit, meter. You know the times unit, second. So it must be meter per second. That's what we do. Okay? That's it.
And for velocity also it is displacement by time is
Meter per second. But along with that, we will also add the directions. Okay? Now, any questions in this? Because we will have a recap. Please go through it and tell me how. Can I have a volunteer? Now, so I am going to make a statement. If the statement is correct, you know the game. You will take the green line. Right? The first one. My speed is 20 km per hour east. Is it true or false? My speed is 20 km per hour east. Is
Wrong.
it true or false?
Red. False.
False. Yes. Please explain. Why is it false? There is no wrong answers. Whatever it is, please. She had 2 flags. We have to take one. That's why she took one. Yeah.
Actually, you mentioned that the car at least direction also, that is called velocity, not speed.
Okay. So this is perfect. You understand? Yeah. So because the direction was also added, it cannot be speed. Okay. Next. When I start from my home, go to work and come back to my home, the total displacement I covered is nothing. Zero. Am I right? When I come back to my home, my total displacement is zero. I see some things. I start from home, go to work, then come back to home. My displacement covered is zero.
That's correct.
Yes, that is right. So those who have answered. Yeah. Because you see, so I am starting from my home, going to my work, and coming back to my home. So I started from this point, I am ending at this point. The shortest distance between the points is zero. Okay. Next. Time is a vector quantity. Time is a vector quantity. Let's. Time is a vector quantity. You think both scalar and vector?
Yeah, that's what I said. Both of them. Time is actually is important for both vector and scalar.
Okay, let's discuss. So yes, ma'am.
Now with the direction.
What red? Why is time not a vector?
Actually, time, we don't say time, this is 9 o'clock towards north, towards west, we don't indicate with the direction. We used to say only the numericals, 9 a.m., 12 a.m., 12 p.m., likewise numericals only, we don't add directions. This is
Exactly. That is right. Okay. So when we ask what is the time, we say it's 5 o'clock. We never say it's 5 o'clock north, 5 o'clock east. We never say. Okay. Next question. Temperature is a scalar quantity. Temperature is a scalar quantity.
Yeah, it's correct.
Whenever I ask scalar vector, just think if you can assign a direction to it or not. For temperature, is it a scalar quantity? Yes, that is right. Whoever got green, that is right. Temperature is a scalar quantity. I cannot assign a direction for it. Okay? Right. So that is it. Now for the questions. Do we have any questions? What is I do? Now you might think, why do we even need this differentiation? Distance, displacement, why do we even need this? This is very important when you go to the next chapter, I mean in 9th standard is the next chapter, and you go to kinematics. We have so much of formulas which will only work with displacement. So displacement is an important quantity for you to know to work with numerics. So that's the bigger picture of this. Okay. I have a question, a simple question. Let's say we have an athlete. He is running in a circular track. Okay. We have an athlete. He is running in a circular track. Let's say he is completing 2 laps. Okay. And the radius of the circular track is something, let's say 100 meters. You have a circular track and radius of that also you know. Okay. If he is completing 2 laps in the circular track, what is his distance? What is his distance? Yes, that is right. Displacement is zero because he is coming back to the same point. What about distance?
time.
This is not know the time here because we are not talking starting from this point, he is covering the circumference for once. Then he is coming again for the second lap, he is covering the circumference for the twice. So when I take the circumference of the circle and multiply that with 2, so that is this. But it gets complicated. In exam, the kind of questions you will get is, when an athlete completes 1.5 laps, what will be this distance? What will be this distance? That is the complicated thing that we get in the exams. Okay. Now, any questions? Right. We will have the worksheets. Yeah, we have a set of conventions, the rules, universal rules. So it's like
SI units.
SI unit. It's like a convention.
SI units because of the second, bigger per second.
I want you to take 10 minutes, discuss among yourself.
அது வந்து distance only magnitude.
Always you can say it's a greater than actually it's a loss of a part.
Either greater or equal, never less than. So is MCQs over?
Yes, sir.
Right. So actually the plan of the lesson should be, right, we will always end with the worksheet and we will discuss the answers of the worksheet in the next class. Okay. So what we do is I will go out and come back again. So we will assume it's the next day. Okay. And we will discuss the worksheet. Right.
Thank you, sir.
Good morning.
Class.
Right. So yesterday we discussed the topic on distance and displacement, and you had a worksheet on it also. Okay. Now I will select two persons who will come here. We will just discuss the answers. Please understand, you will never have the pressure to be right or wrong. Important is that you learn. Okay? Right. You come. Yeah, please go.
Sir, I don't know whether it's right or not.
Two people will go. Ma'am, you please. Please come. Now you just write. Not a problem.
We are not a science teacher, so no problem.
Okay, one question ma'am will answer, the next question she will answer. If she has a doubt, she can ask her also. And that is the pure learning technique. The idea is when we are pairing two people, you have to pair in such a way that one person can take care, the one person should be helped by that person. You have to pair it in such a way. Yes, start. First question.
Distance is a scalar quantity.
Is it right?
Yes. Clap, clap.
Clap, clap. That's good.
Displacement is a dash quantity. Vector quantity.
That is right.
This is a polling has only magnitude and no direction distance.
Right.
Which quantity has both the magnitude and the direction? Speed.
Speed.
No.
Okay.
Velocity.
Why speed is not answer? Because speed is something that has only magnitude. Velocity will have both magnitude and direction. So that is something we have to change. Okay. Good.
A student walks 5 meter east and then 5 meter west and reaches the same point. The displacement is 0 meter.
Very good.
And this statement is correct. And distance is always 0.
No. The distance is always greater than or equal to the displacement.
Good point. Please, you don't have to have knowledge in physics to attend your physics. You don't have only you learn.
Yes. Speed is defined as displacement per unit time. Distance is distance per time.
Velocity is defined as speed without a direction.
Displacement per time.
Displacement per unit time. Even if the answer was speed with the direction, that would have been correct answer. Now it's displacement by time.
Which part contains only scalar quantities, distance and speed?
Yes, correct.
An object that moves from A to B in a curved path, the actual length of the curved path is velocity.
No distance.
Yes. Actual.
Actual path distance.
Now, actually, I think we are more jealous of her. She has learned so much than her. Correct? Thank you. Thank you. Last 3 months, you have finished it. I am so happy. Yes. Very good. Right side is my child. You know what? The model was prepared by that child only. So, shout out to Mr. Charles who did that. It was her idea. She did. So, is that all? Any questions? Right. Thank you so much, teachers. Thank you for your participation. Thank you.